Hello, this is our intermediate algebra course, and the challenge today is, can you find the missing number? You have this picture with a cross. It looks like a gigantic plus sign, and inside you have the numbers 12, 20, 25, and there is a missing number. And outside, I think the hint is about the numbers that you see outside. Between 12, you have 3 and 4. Between 20, you have 4 and 5. Between 25, 5 and 5. And the missing number is between the numbers 3 and 5. Can you find the missing number? It's actually a simple, easy puzzle. And at the end of the section, we will find the answer. Okay, today we will talk about section 6.5, solving equations containing rational expressions. We learn about rational expressions, how to simplify, how to add, subtract, multiply, divide. Now, at the end of the chapters, usually what we're going to have to do with all this knowledge, solve equations. And that's what we're going to do now. The first example, solve the equation 5 over 3x plus 1 equals 7 over 6. Well, the previous questions, when we have only expressions, the question is simplify. We can simplify expressions, but we cannot solve expressions. This is one expression. This is another very simple expression. And when we have one expression equals to another expression, the equal sign, you have what? You have an equation, right? So equation is something that, yes, equation we can solve. The question now is solve. And every time you're solving an equation, you're going to work. At the end, you're going to find x, the variable, equals to something, okay? Solving the equation means finding the value of x to the equation. All right, this is just a review. Now we will solve this rational equation. Every time you have a rational equation, the first thing you will try to find is the least common denominator, right? And check all the denominators, even the integers will have a denominator. You can change, you can transform as a fraction 1 over 1, right? So the least common denominator between the first denominator here is 3x, and the second denominator is 1 and 6. Well, we need to find least common denominator. We need to multiply all the unique factors. 3x, so we have 3, and we have x. 1, we don't need to worry about 1, don't need to multiply. And 6, we can break down 6, right? 6 is 2 times 3. We already have 3, and we just have to use now unique factors that is missing, 2. Then the least common denominator, 6x. Right, now you're gonna get this equation and multiply each one of the terms by the least common denominator. Equals, that's 1 over 1 equals 7 over 6. Multiply the first term by 6x. Multiply the second term by 6x, and multiply on the other side this, we have only one term by 6x. Okay. See, we multiply everything by the least common denominator, and we can do this because of multiplication property of equality, right? You cannot do this kind of thing if you have an expression. You're not allowed to change the expression. If you have an expression, you have to multiply by 6x on the top and 6x on the bottom, remember? But this is an equation, we can just multiply both sides of the equation by 6x. Okay, now 6x divided by 3x is a 2. And this one we don't need. 6 divided by 6 is 1. And now check what happened. We canceled all the denominators. We have only numerators. So not numerators, just have the top, right? Integers and variables on the top. 6x and 7. We still have this x here, 7x. Finally, apply addition property of equality, multiplication property of equality. First, we're going to subtract 6x on both sides. So we cancel out this 6x. And 10 equals 7 minus 6x. That's going to be the final answer. X equals 10. Okay, nice. Always check your answer, especially if you're working with rational expressions. And I say especially because when you check, let's say, an equation that doesn't have any rationals, you're just checking if you did everything right and you found the right answer. When you're checking an equation that have rational expressions, remember, we cannot have 0 on the denominator. If you have an expression with variables, you have to avoid, you cannot have 0 on the denominator, or you're going to have a situation where the value is undefined. So plugging x equals 10 into the equation, and then you have, look, 5 cancel out with 10, because 10, both can be divided by 5. And we will have 1 over 3 times 2 plus 1 equals 7 over 6. This is the same thing as 1 over 6 plus 1, 6 over 6 equals 7 over 6. And you can see, yes, this is true, this is correct. We don't have any zeros on the denominators, and this side here is equals to 7 over 6. All right, these steps we are using to solve rational expressions is, first, find the least common denominator, multiply both sides, every term in the equation, by the least common denominator. Step 2, simplify, then you check if depending on the kind of equation, we will work a lot right now with linear equations, and check if the solution is correct, and if you don't have any denominators that become 0. Solve the following rational equation. First step, find the least common denominator, and let's check each one. We have 2x, we cannot factor out anymore. We have x plus 1 that we cannot factor out anymore. But here we can factor out the greatest common factor, 3x, right? And then times x plus 1. Perfect. Now we will find all the unique factors. 2 is a unique factor. We have also x, a unique factor. We have 3, and look, x is repeated. We will get the one with the greatest power. So just x, both have power 1. And x plus 1 is also repeated. So we will get the one with the greatest power, least common denominator, equals 2 times 3 times x plus 1. 6x, x plus 1. Multiply each term in the equation by the least common denominator. So let me rewrite here the terms. Minus 1 over x plus 1. 1 over. I'm going to write down this breaking down the denominator. Okay, and multiply everything by the least common denominator. 6x times x plus 1 times 1. 6x times x plus 1 times the 1 that was here. Sorry. And again, 6x times x plus 1 times 1. And clean this. All right. And the next step is simplify. Simplify, check what are the factors that are repeated, that are the same on the top, on the bottom. And we can divide 6 by 2, and we have 3. We have x that we can cancel out. We have x plus 1 on this denominator and also on the numerator. And here we can cancel out lots of things. We have x plus 1, we have x, and we divide 6 by 3 is 2. After we remove and we cancel all the denominators, we will have only things on the top, on the numerator, and this is going to be 3 times x plus 1 times 1, don't need to write times 1. 6x, okay, equals, and we still have this 2 and times 1. 2 times 1, you don't need to. All right, and great, because we canceled all the denominators, we all now can solve this simple equation by applying the steps we learned before to solve linear equations, right? The first thing is apply distributive property, then combine like terms, then apply addition property of equality again and again and again until you have all the x's in one side, all the numbers on the other side, and finally apply multiplication property of equality if is the case. So first, distributive property, then you have 3x plus 3 minus 6x equals 2. Next step is combining like terms. We have 3x minus 6x is negative 3x plus 3 equals 2. Okay, let's move this up here. And we will apply now addition property of equality. The objective is to cancel this plus 3, so minus 3 on both sides. And then we have negative 3x, this cancels out, equals 2 minus 3, negative 1. And finally, we have only x on this side, only a number on the other side. Divide both sides by this coefficient, so we can cancel it out. Of course, we don't cancel the x, sorry, we don't cancel the x. X equals negative divided by negative positive, 1 over 3 is the answer. Remember, the answer we find, we need to plug in into the original equation and check if we don't have any denominators that become 0 or any crazy stuff like we make a mistake. In this case, we're not going to have any denominator 0, and if we check, you can check yourselves this the results for this, and okay, we have the right answer. Another example. This example, I will just find the least common denominator, and the rest you can do yourselves. What is the least common denominator? unique factors of each denominators. We have all the denominators here. And let me give you a hint in this case. Every time we have a proportion, proportion is a fraction equals to another fraction. We can use another method. We can use the method of finding the least common denominator, what we've been using, multiplying all the terms. But if it's a proportion, only one fraction equals to only another fraction, we can use cross products, or some like to remember as the butterfly, right? Only in this case, only if you have fraction equals to another fraction, okay? And that's going to be pretty quick. Multiply, cross multiply, and then you have 1 times x plus 1 is just x plus 1 equals 2 times x minus 1. Very simple, very easy. Apply distributive property, and you can finish this one, finding the value of x. X equals to what? And real quick here, I think x is going to be equals to positive 3. Positive 3. Check if I'm right or wrong. Substitute the values into the original equation always, and check if you really got the right answer. What is on that example, on this example now, what is the least common denominator? Let's check each one. Well, 3 plus a is already factor, we cannot factor out, yes, is already the simplest factorization, but we have 9 minus a squared. Remember, this is 3 squared minus a squared. Difference of 2 squares. We can break it as 3 plus a times 3 minus a. The least common denominator equals only unique factors. When you find a repeat, you're gonna use the greatest power. So this is repeat only once, and this is also a repeat, use only once. Multiply both sides, all the terms, by the least common denominator, and you can work this one out to find the answer. Be careful, because when you find the answer here, you probably you're going to do your calculations. You're going to find x equals 3, let's say x equals 3. Then you have to plug in, right? Plug in into the original equation. And we will have a big problem. Look here. 3 minus 3 equals 0. This is undefined. When you find a situation like that, even though you did all the right calculations, you're going to say this equation has no solution. Okay? So always check because of this. Always check. We're also going to have 0 here. Doesn't matter. If you have 1 denominator equals to 0, this is it. Is undefined, is no solution. As you can see, it's very important to check the solutions. What about this one? I will give you the least common denominator. You can do the rest. Let's check. Look, we have to break down this. We also can break down that denominator. The only one we cannot break down is x plus 5. It's already the simplest factor. But this one, this is a simple one. We can find greatest common factor, right? So let me use a different color. 3 times x plus 2. And what about this one? X squared plus 7x plus 10. We can use the guessing method. We are using the guessing method a lot because it's simple, quick, and later we're gonna have formulas that will help us. But the guessing method in this case is quick and easy. Two numbers that multiplied is equals to 10. If you add is equals to 7. So 10 can be 1 times 10, can be 2 times 5. And yes, I think we have something here, right? 2 times 5, 10. 2 plus 5, 7. That is our answer. So x plus 2 times x plus 5. The least common denominator, only the unique factors. So x plus 2 and x plus 2. If you have a repeat, use the greatest power. They both have power 1. X plus 5 is another repeat. X plus 5. Gonna use only once. And 3. Let's write down the 3 here at the beginning. I like to write the number as a coefficient, 3. This is the least common denominator. Well, now it's up to you. Now pause the video, try to work this example by yourself, and after that I will show the answer. Now that's the solution I found. X equals -7/5. And don't forget to check, plugging into the original equation, and I checked it and saw there was no denominator that was made equal 0, and the solution makes sense. I'm quite confident x equals -7/5, but if you found something different, let me know. Okay, all right. Can you find the missing number? That's the challenge. It's a very simple challenge. How do we find? What is the connection? What's the relationship between those numbers? And actually, you can think about least common denominator. Is one way of thinking. Look, between 3 and 4, the least common denominator, or the multiplication between 3 and 2 is 12. Between 4 and 5, the least common denominator is 20, or the multiplication between 4 times 5. Between 5 and 5, the least common denominator is 25. And between 3 and 5, the least common denominator, or the multiplication between both, is 15. But don't forget, not every time we're going to have least common denominator like that. Multiplying this simple way. Sometimes we need to find unique factors. Thank you for watching. Don't forget to answer the questions on MyLab Math, and hope to see you on the next meeting.